In continuation to the last video, now we'll take specific conductivity. Now what is this specific conductivity or specific conductance, or simply can call conductivity? Three terms are what? Same only. Now this will always specific conductance I am taking what? By using this formula. Specific conductance is always equal to reciprocal to what? Specific resistance. Now already we know rho is equal to what we got actually? Resistance into we got A by L, isn't it? Now take now here this one 1 by what we get? R into A by L. Now this we can write what? K equal to 1 by R into L by A. Okay, this is the formula for what? Calculating specific conductance, otherwise specific conductivity, otherwise simple conductivity, isn't it? Now what will be the units for this one? How to calculate the units here? Now our resistance what will take here? Ohm, right? Now here for this one we take units are ohm. For this one what will take units here? Centimeter, right? For this one what will take here? Centimeter whole square. Now substitute this one. K is equal to 1 by ohm into centimeter, or meter also we can take, centimeter whole square. So this will be cancelled. Now specific conductivity is equal to ohm inverse into centimeter inverse. We can also write ohm inverse this one, or MHO also into centimeter inverse here. Okay, otherwise you can also write ohm inverse into, I am writing this one centimeter inverse, meter inverse also, isn't it? So all are what? Same. When you take meter, that will be SI units here. So specific conductance units we got in this way. Okay, now one more thing, we can write ohm inverse also called Siemens. In the last class, last video we discussed this one. Ohm inverse is nothing but equal to capital S. Siemens also we can take here, right? So this is about the specific and conductivity formulas and the units here. Now what I have taken here, specific conductivity definition. What will be the definition now? Very simple. This is a cube here. This cube here. This is the cube which is having length is equal to 1 centimeter, breadth equal to 1 centimeter, height equal to 1 centimeter. Totally it is having volume is equal to what? 1 cubic centimeter. 1 cubic centimeter. That is always equal to 1 ml. Now here you have some electrolyte is having. You are having some electrolyte in this one. Now the conductance of, isn't it? The conductance which is shown by 1 ml of electrolyte is called specific conductivity. I am writing a definition very simple here. Conductance shown by 1 ml, shown by 1 ml. 1 ml or 1 centimeter cube electrolyte is always called as what? Specific conductivity, isn't it? This will be the definition, very simple definition. The conductance shown by 1 ml of electrolyte or 1 cubic centimeter of electrolyte is called what? Specific conductivity or conductivity we can call. Units and everything we already discussed. Now this is we are entire the definition. This is the total definition. Whenever it is having what? 1 unit volume of the solution kept in between 2 platinum electrodes with a unit cross area, everything that is called lengthy definition, but in this way also we can write here. Next we'll take equivalent conductance, isn't it? What is this equivalent conductance? Very simple. The conductance shown by 1 gram equivalent weight. 1 gram equivalent weight. The conductance shown by 1 gram equivalent weight. That is called what? Equivalent weight conductance here. Generally, in our syllabus we don't have equivalent conductance, but anyhow, what is this formula? It can be shown by lambda. The formula will be lambda into kV. K means already you know what is the meaning of K? Conductivity or specific conductance. Volume is in terms of ml we can write here. Now here this I am deriving this V by using what? Normality formula. Here normality is equal to number of gram equivalents into 1000 by volume of the solution. You have taken how many here? 1 gram equivalent? No. So I have taken here what? Number of equivalents equal to 1 gram equivalent. Now volume is equal to what we get here? 1000 by normality. See, if it is 1, this will come here and normality will come here. What we get? Volume is equal to 1000 by normality. So this is the formula we have taken. Okay, this generally we don't have in the syllabus. Next we'll take the molar conductance, isn't it? Molar conductance we'll take now here. Now what is this molar conductance? Very simple. Conductance of a solution having 1 mole of electrolyte, isn't it? In given volume of the solution. It's nothing but actually called molar conductivity shown by lambda m. Lambda m. Otherwise mu also we can use, or lambda m. Generally current textbook will take lambda m actually. Now molar conductivity of a solution at given concentration of that volume of the solution having how many moles? You should have only 1 mole of the electrolyte. When kept between 2 electrodes with a cross section area, then that is called what? Molar conductance. That is the same thing we discuss here. 1 mole of simple thing, 1 mole of electrolyte having 2 electrodes in which the distance between the 2 electrodes is 1 centimeter. Area of cross section is having what? 1 meter, 1 centimeter square. Then that conductance is called what? Molar conductivity. Molar conductance or molar conductivity, isn't it? Now the formula we are using for this one is what? Molar conductivity is equal to, we can write like this is the formula generally be useful for calculating the molar conductivity. Very simple. What is the formula? Very simple. Molar conductivity is equal to what? Again, specific conductance K into 1000 by molarity. If they don't give molarity, what we can take? Mole per liter also we can take. Mole per liter or molarity. With this formula we can calculate what? Molar conductivity, isn't it? Now everything, these are the formulas, right? Molar conductivity is nothing but what? Like this. And why we got this formula? How we got this formula? Actually this will be the formula actually. When you observe here, this is the formula actually. But how we got this formula? Let me see this one. How we got this formula from this one. So again, molarity is equal to what is the formula? According to the 11th class, molarity is equal to what? Number of moles of solute into 1000 by volume of the solution. Volume of the solution. How many moles I have taken here? Number of moles equal to how many? Only 1 mole. See, 1 mole. Here I am writing what? 1 mole. Now volume is equal to what we get? Volume is equal to 1000 by what we get? Molarity. So in the place of volume what I have taken 1000 by molarity, isn't it? 1000 by molarity. So we got this same formula, isn't it? So everything here is very simple. Molar conductance means the conductance of 1 mole of electrolyte, isn't it? Whereas equivalent conductance is the conductance of 1 gram equivalent weight here. Whereas specific conductance means the conductance of 1 ml of electrolyte in which 2 electrodes are separated by 1 meter distance. Area of cross section is 1 meter square. This term will comes for all type of conductance. 1 meter distance, 1 meter square, area of cross section here. Now what is the relation between the equivalent conductance and molar conductance, isn't it? So generally equivalent conductance, molar conductance can be calculated like this. Now when you multiply n factor with equivalent conductors, then we are going to get the molar conductance here. We are going to get the molar conductance. Now molar conductance is equal to n into equivalent conductance. What is this N? N means a Z factor. N factor or Z actually means what? Nothing but valency. For example, you take H2SO4, okay, will dissociate into 2 moles of H plus, giving SO4 minus 2. Now how many positive charges are there? 2. How many negative and positive will always equal? Now N is equal to, in this case here, charge only we have to consider. N is equal to 2. Now molar conductance of H2SO4 is equal to, how do we calculate? 2 into equivalent conductance of H2SO4, right? In this way. For example, you take calcium hydroxide, isn't it? Calcium hydroxide. Now calcium plus 2 plus 2 moles of OH minus. How many negative charges? 2. How many positive charges? 2. Now N is equal to here also what? 2. In this way, we can easily calculate what? Isn't it? Relation between equivalent and molar